today our topic of discussion is CNN, Convolution Neural Network. Now the first thing that I'm going to discuss is that why this network is so popular. Now, whenever I am talking about CNN, remember one thing, there will be one question, that is why this CNN is used, means nowadays why it is so popular. So now the major application of CNN is very simple. It is used in image recognition. Now, whenever I'm talking about CNN, remember one point, it only works on image. Now, here the important point of discussion is nowadays whatever face recognition apps are there, the CNN will be the integral part of those apps. So now what we are going to discuss, say we have a project where we have a large data set of cats and dogs, and these data sets are labeled data set. Why they are labeled data set? Because we know this is the set of data where we have dogs only, and this is the set of data where we have cats only. So these are the labeled data set. Now consider we have large amount of labeled data set, and we have to find out the cats and dogs from a certain image. Means we have to recognize from a certain image which one is the cat and which one is the dog. So now I hope you can understand that CNN is a special type of neural network. So whenever I'm talking about CNN, don't think that it is a new thing. We have already discussed about artificial neural network. This neural network is modified further as CNN. But we will also discuss what are the potential differences between this ANN and CNN. So here my point is, in CNN, in order to perform certain project or in order to perform image recognition or object recognition, we have to follow certain steps. Today I am going to discuss that steps which are very important. So let's start this one. So here my point is, today we are discussing convolution neural network, which is a modified version of artificial neural network, and it is a part of deep learning. Now you have to understand why it is a part of deep learning and which extra component CNN will have. So here, consider this project where we have cats and dogs, and we are giving this input to a particular CNN model in order to recognize cat and dog from a certain image. Now the important point over here is which steps we have to follow. So the first thing you have to remember, in order to use the convolution neural network, first step is you have to perform something on the convolutional layer. Now the important point is each and every layer in CNN will have certain mathematical activity by which it will determine the object or image. Second one is we have to identify what activation function this convolution neural network will use. Then third, we have to find out what are the pooling mechanism it will use, and then only we can proceed further, and you will find that after performing this three step, it will behave like an artificial neural network. So please make a note over here. That is, whenever we are going to perform any project using CNN, we have to follow certain steps. Step number 1, 2 and 3 includes convolutional layer, activation function and pooling mechanism. And whenever we perform these three steps all together, then the fourth step of the CNN will exactly behave like an artificial neural network. That is, it will have one input layer, it will have some hidden layer, we will give some input, and all the inputs will be connected to the hidden layers, and finally we will have some output layer. So this is the basic architecture of CNN. Now we have to understand what are the basic three mechanisms of CNN. These are unique mechanisms used by CNN, and these three mechanisms are not there in artificial neural network. So in nutshell, you can say that these three mechanism plus ANN mechanism altogether will create CNN mechanism. So this is the first point that I'm going to discuss. So I will start from convolutional layer. Now see, before starting convolutional layer in CNN, I will tell you one story. It is very, very important. So whenever we are talking about CNN, I have already explained that CNN works on image. And whenever we are talking about any image, you have to understand a image may have many low level feature, mid level feature and high level feature. Now, in order to understand the CNN working mechanism and meaning of this low level, mid level and high level feature, I am just going to explain you one simple story so that you could correlate this concept. Suppose you saw someone walking towards you from a distance. So what you will do? Your eyes first will try to detect the edges of the person. Means whatever figure is visualized by your eyes, first it will try to find out the edges of that figure. This is the first thing that human eye will perceive. Then what is the second thing? Then the second thing, the human eye will try to differentiate the figure from other object. Means if this person is coming from the road and if we have some building, road, so in the second step, human eye will try to differentiate this figure from other objects. So this is the second thing human eye will try. Now, as the person walks closer towards you, then you will try to focus on the shape of the person. Means trying to deduce whether the person is a male person or female person. So this is known about focusing on the shape. And also you can visualize whether this person is a slim person or he or she is a fat person or not, whether the person is wearing any specs or not, whether the person is tall enough or not. This comes under the third step. So in general, your focus will be shifted from feature to feature when the object is coming towards you. So this is the basic fundamental logic of human eye. Now, whatever mechanism is followed by human eye, the same mechanism is used by CNN. Now, here I want to tell you one important point. Whenever I have explained ANN in class, I have explained that ANN followed the mechanism of biological neuron, which reside inside our brain. Now here, what is the mechanism of CNN? CNN follows the mechanism of human eye. So this is the basic difference you can say between ANN working principle and CNN working principle. So please make a note over here. I guess now you can understand how human eye will segregate features of an object while visualization. So same thing happens for CNN. So whenever we are providing any particular image to a particular CNN model, first it will try to visualize the low level feature. Low level feature means edges of an object, just like a human being. Means whenever a person is coming towards you, you will try to see the edges of the person. Then it will try to find out the mid level features. Mid level feature means you have to focus on the other object, that is apart from this human being, what other object exists. And in the third case, we have to focus on the high level feature, whether this person is a male or female person, slim or fat, whether he or she is wearing specs or not. So here my point is, these are the three basic mechanism on which CNN works. So whenever input image is given to CNN, first it will try to find out different kinds of feature. Starting from the low level detailing to high level detailing, it will proceed further. And then it will try to train itself so that it could give us some output. But see, extracting this all features will take some internal steps, and today we are going to discuss all those steps. So as I have discussed that whenever we are talking about CNN, the first step we have to understand convolutional step that the CNN will follow. Now in order to understand what this convolutional concept in CNN is there, let me explain one simple thing. So up to this we have discussed about CNN model. And we have already discussed whenever we are talking about CNN model, we have to give image as an input. But whenever I am talking about the image, I haven't tell you that what kind of image it is, whether it is a colored image, whether it is a particular black and white or monochromatic image. So here my point is a CNN can take all kinds of image, but we generally focus on color image. So this thing you have to remember. So whenever we are giving input to a CNN model, we have to remember one point: CNN will focus on color image. And why color image? I will explain. Now come to the very basic or starting part of the CNN model. That is, now we are going to discuss convolutional layer. This is the first layer. Now before discussing this convolutional layer, we have to understand the image also. Consider I am taking this image as an input. So this is an image of 9, and there is a data set known as MNIST data set from which we can acquire this kind of image. Now if you consider this image, first focus on the data structure of the image, how this image will look like. Now see, I am talking about colored image, right? And whenever I'm talking about color image, we know that the basic primary colors are RGB. So here we are going to discuss this image in terms of RGB color. So if you focus here, you will find that we have some 9 kind of pattern over here. And we have a very high value of intensity here, and it is creating a shape of 9. And you can also observe here we have 3 basic frames. One frame is used for red, one frame is used for green, and one frame is used for blue. So what I mean to say is that whenever I'm talking about image, a particular image will have many pixels, but you will have only one frame whenever you have black and white image, because in black and white image either you have 0 value or 1 value for a particular pixel. But whenever we are talking about colored image, this colored image, for each and every pixel you have 3 color: R, G and B. And if you collect all the intensities together, then the output value of the pixel will be displayed. So here my point is, if you have any other value apart from 0 and 1 for a particular pixel, definitely it is a colored pixel. So I hope you understand what is the meaning of this 255. 255 means it is the intensity, and rest of the intensities are 0. Means the pattern of the 9 will be displayed in this region. So we will have high intensity value of the pixel in this region only. So that's why I'm talking about colored image, and you will find that for displaying this colored image, we have 3 separate frames, one for red, one for green and one for blue. So this is a very simple data structure that we are using. And why I am explaining this thing? Because now I am going to give this colored image as an input to the CNN model. Now we have to discuss how it will work. But before that, we have to understand one more thing. So the first component in the convolution layer is the colored image. And we have already discussed about the data structure of the colored image. Now, the second component is known as filter, or it is also known as kernel. Now, what is this filter? I will discuss. But for the time being, you have to understand one point, how this convolutional layer will work. Convolution layer will take colored image as an input, and then it will multiply it with a filter or kernel, and then it will produce some set of features. So the question is, what is the main purpose of using convolutional layer? Convolution layer basically performs multiplication between input image and a filter, and then it will produce some kind of features. Now, before explaining this convolutional layer in details, I want to show you one video. Now see, as I have stated that we will have some input image, and input image will have some intensity value for each and every pixel. And then we will use one filter. Now, what is the objective of this filter? Basically, this filter will slide over this input. It is known as sliding the kernel. So we have to slide all this kernel over this image. And see, we have a multiplication symbol over here. So whatever input image pixel values it is containing, we will slide this kernel over this, and we will multiply this value with the kernel, and we will create some feature map. Now, what is the most important thing? See here, there will be one question. Okay, ma'am, we have understood that input image means we have pixels and it will have many intensities. But see, we have certain value in the kernel. But how one can understand what should be the value of the kernel? Because this value is not defined in the input image. So in the input image, we will slide some box, and then whatever value we are getting inside a box, we will multiply all these values with the individual pixel value of the kernel, and then it will produce some particular pixel value in the feature map. So here my point is, what is the value of this kernel? It depends on what is the purpose of your operation. For an example, see here. If you want to create a very sharp image using convolutional neural network, then this will be your kernel value. So if the operation is image sharpening, then we have to understand this is the standard value of the kernel that will give you a sharper image. But if you want to create identity image, means whatever image you have, you want to generate that image exactly using CNN. So this will be the filter value. See, this is the identity filter. If you want to detect only the edges of the filter, so there will be different kinds of edge selection mechanisms. So if you change the value of the kernel, accordingly you will find different edges of the picture. And if you want to create a blurred image using CNN, then this will be the kernel value. I hope it is clear how this kernel value will be selected. So here my point is, after placing our filter over the selected pixel, we take each value from the kernel and multiply them with the corresponding value of the image, and then we sum up all the values, means whatever we are multiplying by taking value from the kernel, and we will have value of the pixels over here. After multiplying, we sum up all the values, and then finally after summing up, we put the result in the correct place of this matrix, and feature map will be created. So this is the very basic mechanism you have to understand. So here my point is, if somebody is asking what is the first step in convolutional neural network, you can say that the concept of convolution is the first step in convolutional neural network. Here this step is also known as kernel convolution. Why it is known as kernel convolution? Because in this step we will use filter or kernel with the input image. So here in this process what we are doing, we are taking a small matrix of numbers. This one, this is basically a matrix. This is a very small matrix which depends on the operation that we want to perform. So first we take a small matrix which is also known as kernel or filter, and we pass it over our image or slide it over our image and transform it based on the value of the filter, and we will get as a feature map. So basically here we are multiplying and then we are summing up all the values to create the feature map. So this is the first step of the convolutional neural network. And we'll find one formula. In this formula, whatever I have discussed, it is written over here. So here we are calculating one multiplication of f and h. H is the kernel and f is the image, and then we are summing up all the values in order to create the feature map. So this is the first step. So whenever I am talking about convolutional layer, we have understood the concept of kernel, we have understood the concept of input image, and how feature map is created, we have understood. But the first question is, which is very important question, why the size of the image should not equal to the kernel size? Means if this is the image size, say it is a 3x3 image for an example. So we are multiplying this image with a kernel value. See, the size of the kernel is always less than the size of the image. Why? So the first question is, why the size of the image should not equal to the kernel size? See, try to understand. If we choose the size of the kernel, means this one, smaller, then we will have lots of details. For an example, say this is my input image. So from input image, say I have got lots of pixel information like this. And if I am selecting a very small kernel value like this, so what will happen? It will extract many information from each and every pixel. It can lead you overfitting. Why overfitting? Because in the class I have explained that whenever you are learning so many information, there will be a chance of learning some noises also. So if the kernel size is very small, it will slide over the image and it will extract each and every detail information of the image. So as a result, it will create overfitting situation. And also, if it is extracting so many information from the image, what will happen? The computational complexity will increase. So if the kernel size is very small, we are not accepting that. Now say we choose the size of the kernel large or equal to the size of the image. Say if the image size is n cross n and if the kernel size is also n cross n, if it slide once, it will fetch all the information from the image. So as a result, what will happen? It will only create one neuron or one information from the image. But basically in the previous discussion I have explained that from image we have to extract so many detailed information, means shape of the image, we have to segregate this image from the other object, detailed information we have to extract. But if the size of the kernel is same as the size of the image, so it will extract only one information and it will result in underfitting. So this is the most important thing you have to realize. So I hope the confusion on filter or kernel is clear. The first question was, do we need to remember the filter values? My answer is yes, because the value of the filter will change depending on what kind of operation we want to do. Second, we have to remember the size of the filter. The answer is yes, we have to judge the size of filter in such a way that it should not be too large or it should not be too small. In general, people will use either 3x3 or 5x5 kernel. And in more application, 3x3 kernel will be enough. So I hope the first layer, that is the convolutional layer, is clear to you all.